those who are not able to attend. And let me share my screen. Okay, so today is Wednesday, February the 8th. You have 4 assignments that are due by Sunday. You have the Module 2 exam, class participation 8, which deals with confidence intervals, which was our discussion on Monday, and then the homework for the Z interval and the T interval, which again are both related to the confidence interval discussion that we had on Monday. Today, we're going to begin looking at the hypothesis testing process. And I do not know if we'll be able to get to examples or not. I'm hopeful that we will, but we're not necessarily scheduled to on our outline for today. Yesterday, about 3 o'clock, I posted a set of fill-in-the-blank notes. When we were forced to go to remote learning in spring of 2020, and then that summer we also ran remote classes through Zoom, I created this document to help students with their note-taking related to this topic. And so I have continued to use those in the Zoom format. So I've made those available. I don't know if you have the ability to print them off and fill them out, or if you can fill them out on the computer while you are in the Zoom room. But our topic is for this today is hypothesis testing. And this is actually going to be our focus in the course for the rest of the term. Okay, we're in week 5, so we have about 3 weeks left, and we're going to be using or talking about hypothesis testing through the rest of the time. We're going to look at it, a variety of tests or statistical analyses which involve hypothesis testing. So this is an important topic. It's one that obviously you need a good understanding of. And so what I want to do, at least initially, is walk through the steps. And the steps honestly do not change from problem to problem. The piece that does change is what test statistic do we calculate? And that's based on the information that we have in the problem or the type of data we have. And I have that listed towards in about the middle of the document so we can talk about which test to use when. So I'm going to dive right into these notes. I hope that you have printed them off or have access to them while we are within this discussion. But again, before I begin, do you have questions related to confidence intervals that I can address before we get into this discussion? Okay, we know, or we have talked about several times in the course, that most research, or really all research, statistical, scientific, whatever, begin with a question. The question could be, what is the most popular vehicle manufacturer? Driven by GHC students in spring 2023. What is the most popular color for people living within the United States? What is the average age of a GHC student in spring 2023? It could be a variety of questions. And then that question leads us to conduct a study or research. But one of the things that we really didn't talk about in that process, if you go back to our statistical research process, where step one is to state the question clearly with as much detail as possible, so that you can do step two, where you identify the population, the parameter, the variable, the sample, and the statistic. There's kind of an intermediate step that we really didn't talk about. And that step is that typically when we begin the research, if there's something we want to know about, some question we have, we also have in our mind, in our thought process, we have an idea of what the answer to that question should, could, or would be. And then we go through the process of conducting that research so that we can verify or possibly disprove what we think the answer should be. And that process that we go through, part of the analysis that we do on our data after we've collected it and organized it into our frequency distributions, looked at the bar graph, the circle graph, histogram, box plot, and so forth, is we conduct an analysis called a hypothesis test. I hope that you perhaps have heard that word hypothesis before, probably in a science class. A hypothesis is an educated guess, or we can think of it as a proposed answer excuse me, to our research question. And then there is a process, a very, I don't know that it's a rigid procedure, but the procedure is pretty much the same steps every time that we walk through to either verify, prove our proposed answer, or to possibly disprove that particular proposed answer. So we're going to walk through those steps in the hypothesis testing process. The first step in the process is to state the two opposing hypotheses, and that may be a little bit different from what you would see in a science-related class. In statistics, we have two excuse me, opposing hypotheses. The first one we call the null hypothesis. The symbol, we use a capital H for hypothesis, and it has a subscript of 0. 0, null is an old-timey word, an old English word that implies none or zero, so that's why the subscript is 0. So the null hypothesis is a claim about a population parameter that is assumed to be true throughout the entire process. It must always contain equal in some form. If you think about the idea of hypothesis testing, sort of like a court case or a jury trial, within the United States, we say that a person is innocent until proven guilty. And so we assume a person is innocent. In the hypothesis testing process, we assume the null hypothesis is true, accurate, valid, until we prove otherwise. It does say here that we test, it's a claim about a population parameter. For our purposes in this course, we're going to focus only on the population parameter of the mean. You can also do or conduct hypothesis tests on the standard deviation, on the variance. It could be a proportion. Okay, any of our population parameters that we've talked about, mean, median, standard deviation, variance, any of those we can conduct a hypothesis test on. Again, our focus in this course is going to be specifically on the mean. The other piece that is very, very important here is that your null hypothesis will always contain equal in some form. There are three options of the symbols that you could have in a null hypothesis. You could have equal, you could have greater than or equal, or you could have less than or equal. And one of the biggest decisions that you as the researcher or you as the reader of the scenario in this case is going to have to make is which one of those symbols do you have? And it is totally based on the phrasing or the wording of the problem. You are going to have to read very, very, very carefully. The second hypothesis, and let me change colors. The second hypothesis is called the alternative hypothesis. The symbol is a capital H with a lowercase a. And it is a claim about a population parameter, the same parameter that you had in the null, that is the exact opposite of the null. It will never contain equal in any form. So the null and the alternative are opposites of each other. Again, think about guilty, not guilty. They're opposites of each other. Again, for our purposes, the population parameter that we're focusing on is only going to be the mean. The math symbols that you could see in the alternative would be not equal, it could be less than, or it could be greater than. And guys, they're paired up that way. I wrote it that way for a reason. Equal will always pair with not equal. Greater than or equal will always pair with less than. less than or equal will always pair with greater than. So I kind of tried to line them up. Again, they're exact opposites. And one of those hypotheses has to be stated in the given scenario. Again, you as the reader will have to make the decision about which one you have. Now, as a researcher, if you were doing this from scratch, again, you would make the decision about what your hypothesis is going to be because you would have that proposed answer in your head. The alternative hypothesis, and I'll emphasize that here, so let me write that in. The alternative hypothesis determines the type of test. And you're going to need to know which type you have when you are conducting the analysis, whether you are conducting the analysis by hand, which we're not going to do, using Minitab, or using some other form of technology. You have to know which type test you have because that affects the calculations. Now again, Minitab is going to do the calculations behind the scenes for you, but you have to tell it initially which type test you have. And there are two types. Okay, there are two types of test. The first one is called a one-tail test. And it occurs if the alternative hypothesis contains either less than or greater than. Now, I'm going to try to give you a visual of what that means. Our hypothesis test is usually based on the normal distribution. So normally we're thinking about our bell-shaped curve with the mean in the middle. If we are trying to say that a particular value is less than the mean, less would be somewhere on the left-hand side, and there would be this region that if I fell into this area that was less, then that would be kind of indicate to me that it is false. Okay, and it'll all come together when we start working at a problem. But notice how you only have this one area on the left that is the less than. Okay, so let me write less than here. This is the less than. It only has one rejection region. That rejection region is on the left. That's why it's called a one tail, because there's one rejection region. You could also hear this referred to as a left tail because that rejection area is on the left. Different authors, different researchers use different terms. There's only one rejection region, so it's a one tail. More specifically, it is a left tail because the rejection region is on the left. Similarly, if we're trying to claim that our value is greater, that one's kind of sloppy, sorry, kind of greater than the mean, then we would have our area would be to the right of the mean because greater values are to the right. So we again would have a rejection area to the right. And there's only one because there's only one way to be greater than. And so again, you only have one rejection region, so it's called a one-tail test. More specifically, because the region is on the right, it would be a right-tail test. The other option is we could have is called a two-tail test. A two-tail test occurs if the alternative hypothesis contains not equal. With not equal implies the parameter could be less or it could be more. It's just not the same as the mean. So I have the possibility then that I could be less, which means I would have a region to the left, or it could be more. It's just not the same or not equal. So again, with this particular picture, if you look at it, there are two regions, hence the word two-tail. So this would be a two-tail test. And again, you have to be able to identify which type test you have in order for Minitab to correctly perform the calculations. And you make that determination by looking at the symbol in the alternative hypothesis. Now, Jewel, if you have a question or if I'm going too fast, you can chat at me, speak up, or whatever. Okay. But again, we pose our question. We have our proposed answer, which is our hypothesis. I actually have two because I have the null hypothesis, which will always and forever contain equal, and I have the alternative, which is the exact opposite. And the alternative also helps me to identify my type of test. The second step then is we would go out and we would collect the data. We would actually collect the sample data and calculate the descriptive statistics ourselves. That's kind of the reality if we were doing it in the real world. Again, for this course, I don't have time to send you out to collect the data. So you will be given the information that you need to work the problem in the scenario. So in the reality is you would go out, collect the data, calculate all your descriptive statistics, create all the pretty tables and graphs, and then use those. But for us, you're going to record, which means to write down, the given statistics or the given information. Okay, all of the information that you need will be given in the problem. Okay, the information, what information do you need? Okay, the information needed depends on which, and I think I've got extra words there, which test is being conducted. Okay, which type of test are we doing? And again, there's a variety of tests that we're going to talk about. Okay, the information needed depends on which test is being conducted. And again, we're going to study a variety of tests. We're doing a 1 mean Z, a 1 mean T. We are doing chi-square, goodness of fit. We are doing analysis of variance. And we're also doing correlation. So there's about 5 that we're going to talk about. Should you take the next course, which is Stat 2401, then we also talk about some others. But those are the 5 that we focus on in this course. So step 3 is we gather all of our information that we need to work the problem. And that's given in the scenario. Okay. So then step 3, once we've gathered that information based on reading the problem, we need to determine which test to conduct. Again, I've got extra words in there. I apologize. And so I'm going to walk through the information for the first 2, or really for all 5 that we're going to focus on. For the Z test, and specifically it is a 1 mean Z test, you have quantitative data. Remember, quantitative data is numbers. N, which is your sample size, is greater than or equal to 30. Okay, remember that's your sample size. So N, the sample size, is greater than or equal to 30. The population standard deviation is given or known, and this particular test relates back to the normal distribution that we talked about at the end of Module 2. So for a 1 mean Z test, you have quantitative data, which is numbers. Your sample size is greater than or equal to 30, and you know the population standard deviation. In order to work the problem, the statistics that you need, the information you need are the population mean, which is represented by the Greek letter mu, and that value comes directly from your hypothesis. You have to know the population standard deviation, which is sigma. That'll be given in this problem. You have to know the sample mean, which is X bar. It's given in the problem. You have to know the sample size, which is N, and that is given in the problem. And then you have to know the level of significance, which is represented by the Greek letter alpha. Now, I'm going to toggle back over to a clean sheet of paper, just to remind you what the level of significance is, okay? The level of significance, remember on Monday, we talked about confidence intervals. And the confidence level that we talked about in relationship to confidence intervals is the probability of a success, the probability that it happens, okay? Or think about it as the probability of being correct. How confident are you in your results? And again, the more popular confidence levels were 90%, 95%, and 99%. I did mention on Monday that if we had that idea of the confidence level, which was the probability of a success, then you do have on the opposite side probability of failure, or the probability that you're incorrect or wrong. That is called the level of significance, or you could call it significance level. And together, those two things have to add to 1 or 100%. So if the confidence was 90%, the level of significance was 10%. If the level of confidence is 95%, the significance level is 5%. And 99%, the level of significance would be 1%. One of the other differences that I pointed out is that typically your confidence levels are given as percentages, but your level of significance is usually written as a decimal. Okay, so when it should identify in the problem what your level of significance is. And again, typically that is going to be presented as a decimal. Then we have the second one we're going to talk about is a t-test. And again, more specifically, it is a one mean t-test. Again, a one mean t-test deals with quantitative data. So you'll have numbers. Your sample size is less than 30. The population standard deviation is not known or given. And this particular one is related to the student's t-distribution, which again I introduced you to on Monday. It's related back to the student's t-distribution, which we talked about with the t interval. The statistics that you need, again, you still have to have your population mean, which is the Greek letter mu. And again, that is the value that's in the hypothesis. The sample standard deviation is usually given or known, but you do not know the population standard deviation. You still have to know the sample mean, which is x bar. You still have to know the sample size, which is n. And again, you have to know the level of significance, which is alpha. We will be talking about the one mean z-test and the one mean t-test in Module 3. The other three that are listed here will be our topic of discussion in Module 4. Okay, in Module 4. For goodness, chi-square goodness of fit, it is one of the few statistical analyses that we can use with qualitative data. So we will revisit qualitative data briefly at the beginning of Module 4 when we talk about chi-square goodness of fit. I will give you more details then about what information you have to be given. With analysis of variance is kind of a combo deal, if you want to think about it that way, because we have quantitative data, we have numbers sorted by a qualitative variable or by a categorical variable. So we have numbers that are sorted into categories. So it's kind of a combination deal. Again, that's a topic that we'll talk about more in Module 4. And then the last piece, or the last thing that we talk about in the course, is correlation. And it deals with what we call bivariate quantitative data. We finally dip our toe into having more than one variable at a time. Okay, bivariate means two. So we'll be looking at two variables at the same time, and both variables will be quantitative numbers. And again, that is our focus in Module 4, and we'll talk more about it in detail. So continuing on with this process, and again, I have a typo. We're going to be using Minitab, not a free website. Okay, we will use app.minitab.com. Using Minitab, we will calculate and record, which again means to write it down, the test statistic and corresponding p-value. And we're going to talk about what a p-value is in just a minute. So it's kind of like, again, thinking about it as a court case. We start out assuming the person is innocent until proven guilty. In statistics, we start out assuming our null hypothesis is true. We gather all of the evidence, and the evidence is presented to the jury. We gather all of our evidence, and we calculate that test statistic. That's like the presentation to the jury and the p-value. Okay, so all of that collection and calculating the test statistic, that's like our evidence. Okay. Now, the idea of a p-value, or what is a p-value, is a kind of a challenging concept for students. Okay, but a p-value is a probability value. It stands for, we use P, first letter of probability is a P. That's why it's called a p-value. The p-value is the probability of getting the same test statistic over and over and over again if the null hypothesis is true. That even if we had 3 or 4 different juries hear the case, they would still all come to the same conclusion, that results from another random sample will be as extreme or more extreme than the results of the given sample. Now, I don't tend to get caught up so much in all the theory. Okay, it's more important that you know how to use, interpret, apply that p-value than it is that you fully grasp what the p-value is. One thing that I will say that is extremely important for you to remember, if the p-value is a probability value, remember that all probability values are between 0 and 1. So a p-value, which is a probability value, will never ever be negative, and it will never ever be bigger than 1. It has to be between 0 and 1 because it is a probability. So we gather our evidence, we present it to the jury, then the jury goes out to deliberate, to think about whether they believe the person is guilty or not guilty. So that is step 5. Step 5 is we make a decision to reject the null hypothesis or fail to reject the null hypothesis by comparing the p-value to the level of significance. Okay, that's the standard. We compare the p-value to the level of significance. And again, notice the phrasing. We either reject the null or we fail to reject the null. Remember at the beginning, we've assumed the null hypothesis is true, just like we've assumed the person is innocent until proven guilty. And when we get to the end in the court case, we either come back and say, the evidence proved to us that the person is guilty, or there's not enough evidence and we believe they're not guilty. So everything is in terms of guilty or not guilty, or in terms of the null hypothesis, because that's what we assumed to be true at the beginning. The other piece that is extremely important here is this phrase, fail to reject. You should never, ever say that we accept the null hypothesis. The appropriate, correct phrase is fail to reject. Again, think about the court case. We don't come back and say the person is guilty or innocent. The jury comes back and says they're guilty or not guilty. They could still have done the crime, but the evidence didn't prove it. But if we had more evidence or different evidence, we could have come to a different conclusion. Okay, so we never actually accept the null hypothesis as being 100% absolutely, totally positive, true, accurate, or valid. It's just based on the evidence. This is what we can say. Here are your guidelines. Here's how you decide whether to reject or fail to reject. These guidelines are the same for every hypothesis test that you conduct, whether you're doing the one mean Z, the one mean T, the chi-square goodness of fit, the ANOVA, or correlation, or whether you're doing some of the others that we don't even talk about. These guidelines never, ever change. And here's what it says. If the p-value is less than, let me write it in words for you, is less than or equal to the level of significance, then you reject the null hypothesis. In symbols, we write P is less than or equal to the level of significance. We reject the null. If the p-value that you get from Minitab calculations is less than or equal to your level of significance, you will always reject the null. If the p-value is greater than the level of significance, then you fail to reject the null hypothesis. In symbols, we write if P is greater than alpha, we fail to reject the null. The last step is to write a final conclusion in terms of, I'm going to use the word true. It really should be in terms of the null hypothesis, but it makes more sense for students if I say in terms of the true hypothesis, including the level of significance. Okay, including the level of significance. Okay, that's the process. We have really an hour and a half left. I'm not going to spend all of that time doing it, but I want us to take a look at a couple of examples, at least to think about the one mean Z test. Okay, the one mean Z test, so that we can begin to see how this works. Okay. All right. So the examples are at the end of this document, and we're going to get into them. I'm going to see if I can make us some space. And I'm going to try to go as slow as I can to make sure you get all of the pieces. Initially, these problems, the scenarios, are 3 to 4 sentences long, so it's a paragraph. You need to read the paragraph from beginning to end before you do anything. So it reads, a manufacturer of chocolate chips would like to know if its bag filling machine works correctly at the 438 gram setting. It is believed that the machine is underfilling the bags, thus cheating customers. 37 bags were sampled and found to have a mean of 435 grams. Assume the population standard deviation is, got a typo, 14. Using a 0.05 significance level, determine if the bag filling machine is underfilling the bags, meaning it puts less than 438 grams. Now, one of the first decisions, and I don't know if it has to be the absolute first, but I tend to think about which test am I going to do? And at the moment, we haven't looked at multiple tests. Okay, but when you go to take the Module 3 exam, you're going to have to decide, is it going to be a 1 mean Z, as in zebra, or is it going to be a 1 mean T, as in tiger? The way you decide is whether or not you have the population standard deviation. If you go back to the guidelines above, if I know the population, go back up here. If I know the population standard deviation, I'm going to do a Z. If I don't know the population standard deviation, I'm going to do a T. So if I scan back through this problem, in about the 4th sentence, it says, assume the population standard deviation of or is 14. Okay, so very clearly in that sentence, I am given the population standard deviation, which means I'm going to do a 1 mean Z test because I know the population standard deviation, which is sigma. Identifying which test to do then also identifies for me what information I need in order to work the problem. Okay, because again, if you go back up to step 3, I tell you, you need the population mean, the population standard deviation, the sample mean, the sample size, and the level of significance. And all of that should be given in the problem. Before I go back and identify that information, though, I then want the second piece here is to state the hypotheses. If you're doing it by hand, as I'm doing it here, typically you'll see your hypotheses written. You have H sub O, which is the null. It is usually written on the top. And the alternative H sub A is on the bottom. They're stacked kind of on top of each other, and you have to clearly label them. So you'll see me write every time I do this, H sub O, H sub A. The null is always on the top. The alternative is always on the bottom. You could write them side by side, but again, normally you'll see them stacked. I believe on the homework and in D2L, this is two separate questions. It'll say, what is the null hypothesis? What is the alternative hypothesis? Okay, so let's go back up here to the problem. The hypothesis can be stated in several different ways and in several different places within the problem. I know because I wrote most of the examples that we work here in class, that I have it set up a particular way to try to help you. And I have it so that typically towards the end of the problem somewhere, you're going to see when you're looking for that hypothesis, there are some words you can look for. You can look for words like conclude, claim, believe, think. I think this one actually uses the word determine. Now, that's not a comprehensive list, but those are some of the key words you can look for. In this problem, it's actually stated twice, okay? Because it says they want to know if the bag filling machine works correctly. And then it says it is believed that the machine is underfilling the bags. And then if you get to the end of the problem, it says using determine if the bag filling machine is under filling the bags. And then it defines for you what it means if they're under filling the bags. So sometimes your hypothesis can be stated maybe twice, once towards the beginning and then again at the end in a question form. So my hypothesis here, as I'm trying to figure out, is the machine underfilling the bags? Because if it is, it's cheating the customers because the bag says it contains 438 grams. So it defines for me that it is less than 438 grams. So let's think about this word, and I'm going to write it down here. Okay. The phrase is less than 438 grams. You, as the reader of this problem, have to decide, is that statement the null or the alternative? And it all depends on the math symbol. Less than, when I think about less than, I would think of this symbol. Notice that that symbol and that phrase less than does not contain, equal in any shape, form, or fashion. Because it does not contain equal in any shape, form, or fashion, it has to be the alternative. This statement from the problem is the alternative hypothesis. It is the alternative, again, because there's no equal. When you write your hypothesis, you have to include the population parameter. We're talking about the mean. So the mean is less than 438 grams. That is the alternative hypothesis. It's the alternative because the phrase less than 438 does not imply and does not contain equal at all. And I'm trying to be deliberate, Jewel, because this is the part that students struggle with. And if you get the hypotheses wrong, then it affects everything you do after that. So I'm trying to be very deliberate. So if you are have questions, please let me know. We can then figure out what the null should be, because the null has to be the exact opposite of less than. And again, if you go back to the very beginning under step 1, again, remember I paired these up for you. If it's less than in the alternative, then it has to be greater than or equal to in the null. So it's the same statement. It is the population mean is greater than or equal to 438 grams. Now, just as a side note, I'm going to mark this. This was the one that was given in the problem. You have to figure out the null for yourself, but it's not difficult to do. It is the exact opposite of the alternative. So there's our hypotheses. The second step is, I call it identify the players. You have to identify all of those given statistics. Okay, so the players are the given information or the statistics from the problem. Now, if I'm doing it paper and pencil as I'm doing it here, I usually create a table for myself. I would have to identify mu, which is the population mean. I don't necessarily write out these words every time, but I'm going to write them out for you. I have to have the sample mean. Oh, I'm sorry. Let me put them in this order. Sorry. I have to know the population standard deviation and then the sample mean. Now, I know that Minitab prefers to use the confidence level. So you need to be able to figure out the corresponding confidence level. So I put that off to the side there because you're going to need to figure that out in order to do the calculations in Minitab. But these were the 5 things we listed in part 3, step 3. Population mean, population standard deviation, sample mean, sample size, level of significance, and we need to figure out the corresponding confidence level. All 5 of those things are given in the problem. Okay, the population mean itself is the value that you have in the hypothesis. And so for this problem, that would be the 438 grams. And then I'm going to have to go back and read the problem again. It says, let's see, maybe I can use color code it here for you. Manufacturer, I'm going to the 3rd sentence. 37 bags were sampled. Okay, so at the beginning of the 3rd sentence, it tells me that my sample size was 37. Okay, 37 bags were sampled. Continuing as I read that sentence, it says, and found to have a mean. Okay, so this mean is, it doesn't literally say sample mean, but it's talking about the bags that were sampled. Okay, so that implies that's my sample mean of 435. So my sample mean was 435 grams. Then my 4th sentence, which I have highlighted in yellow, says assume the population standard deviation is 14. So my population standard deviation is 14. And then finally, in the last sentence, it says using a 0.05 significance level. So my level of significance is 0.05 or 5%, which means my confidence level is 95%. Remember, the confidence level is 1 minus the level of significance. And we write it as a percentage. So I have all of my information. Okay. Let me check something for you real quick. I want to look at this PowerPoint for you. Okay, I need to put my updated PowerPoints in there. Okay. I'm going to have to give you the keystrokes to Minitab here. Okay, because once we've identified all of that information, then we're going to go out to app.minitab.com to do the calculation. And let me pull the keystrokes and then you can write them down. Give me just a minute. Well, too much open. All right, here are our steps. And I'm going to put them over here on this piece of paper. And then we're going to walk through them. You'll actually see that it's very similar to the confidence interval that we did on Monday. Okay. But again, we go stat, basic statistics, and we choose one sample Z. We have summarized data. We have to enter the sample size, the sample mean, the known population, standard deviation. But this time we're going to tell it we want to do a hypothesis test. On Monday, when we were doing confidence intervals, we weren't doing a hypothesis test, but now we are. We have to enter the hypothesized mean. And then on the options, we have to enter our confidence level and choose the appropriate alternative hypothesis symbol. This step here where you select the appropriate hypothesis symbol is where you're selecting the type of test. Is it a one-tailed test or a two-tailed test? And again, that selection affects the calculations. Okay, so these will be on this document so you can follow them through. But let's go out to Minitab, and I've got to pull it up. Okay, so I'm in Minitab. I'm going to Stat, Basic Statistics, one sample Z. Again, I have summarized data. My sample size was 37 bags. The sample mean was 435 grams. The known population standard deviation is 14. I'm going to click this box that says Perform Hypothesis Test. My hypothesized mean was 438. Then I click Options. We are using a 95% confidence interval. And let's go back and double check. Remember that my alternative hypothesis was less than. So in this box next to alternative hypothesis, I click on the drop-down arrow and I need to choose the less than symbol because that is the symbol that is in the hypothesis for the problem. Because the question said, determine if it is underfilling the bags, which is less than 438 grams. So I'm going to choose less than. Then I click OK. And I click OK. And I get lots of information. Okay. It gives me the descriptive statistics, but I'm going to scroll down to where it says test. I find the blue header that says test, and I'm going to copy this over to my paper so we can talk about it. Okay, so we go to Minitab and we get our results. I need to write down my z-score, my z-test statistic is this. They call it the z-value. This is my, whoops, sorry about that, test statistic. Specifically, it is a z-test statistic. So my z-test statistic is negative 1.30. The corresponding p-value, and every test statistic has its own unique p-value, okay? The p-value is the second piece here, okay? That is your p-value. They're clearly labeled, okay? Remember, that's a probability value, and it should be between 0 and 1. It should not be negative, and it should not be over 1. And it's not, okay? So my p-value is 0.096. Now I'm ready. I've got all my evidence. There's my evidence. And I'm going to use that evidence to make a decision. So the next step in the process, which is step 4, is to make a decision. And remember, our decision is either to reject the null or fail to reject the null. Remember the guidelines. We reject the null if the p-value is less than or equal to the level of significance. We fail to reject if p is greater than the level of significance. So to make a decision, I have to compare the p-value, which comes from Minitab, to alpha, which is the level of significance, which is given in the problem. It was given as 0.05. My p-value from Minitab was 0.096. Now, for whatever reason, comparing these decimals is, again, one of the areas where students struggle. The best thing I can tell you is to do it digit for digit. Look at the first number after the decimal point in each number. They're both 0. Then I'm going to look at the second number in each decimal value. So I have a 9 compared to a 5. 9 is greater than 5, so 0.096 is greater than 0.05. Since the p-value is greater than alpha, I will fail to reject the null. Now, basically what that means, okay, what does that mean if I fail to reject the null? That means the null hypothesis is true or valid based on the evidence, which in our case is a sample. So based on the sample of the 37 bags, we fail to reject the null, which means the null hypothesis is true. So if I go back up here to my hypotheses for a minute, okay, we fail to reject the null, which means the null is true based on the evidence, and the alternative then by default would be false. So when I write my conclusion, I have to write my conclusion in terms of the hypothesis that was true. What the evidence showed is that the machine is putting 438 grams or more in the bags. It is not underfilling the bags, which is a good thing because we don't want to cheat customers. If I'm putting a little bit more in the bag, I'm good. Okay, so here's what we write. You must include the level of significance. So I always start the sentence with a level of significance. So at the 0.05 level of significance. And there's lots of ways you could write this. We could say the bag filling machine is not underfilling. Whoops. Left out a letter there. Sorry. Underfilling the bags at the 438 gram setting. And you may go, well, Miss Ralston, how did you come up with that sentence? Well, again, based on the fact that the null hypothesis is true, and if I go back to the phrasing in the original problem, we had said it is believed that it's underfilling the bags. Well, I proved by the evidence that it was not underfilling. So I basically took the sentence from the problem and added the word not, because it was not underfilling the bags. Now, again, there are other ways you could say it, but whatever you say has to imply that the bags are not being underfilled, that they're getting the right amount or maybe a little bit more. I could have said is filling the bags to the 438 gram setting or more. I mean, there's lots of ways you could say it. Now, I realize that's only one example, and I realize it's taken me a long time to do it. But again, I'm trying to be very deliberate to hopefully help you grasp the concept and not make the common mistakes that students make. I am going to work through another one, but do you have a question or any questions before we look at a second one? Okay, let me see if I can bring this one up on the page. All right, the second example here says an automobile manufacturer claims that their car has a 45.6 miles per gallon rating. An independent testing firm has been contracted to test the miles per gallon for this car. After testing 240 cars, the independent testing firm found a mean, miles per gallon of 45.5 with a population standard deviation of 1.1. Is there sufficient evidence at the 0.01 level of significance to show that the cars have an incorrect, not equal manufacturer's miles per gallon rating? Okay, so again, the first decision, at least at this point, that you're going to have to make is which test are you going to conduct? And again, you're deciding between a 1 mean Z and a 1 mean T. And the difference between those two is whether or not you know the population standard deviation. So again, if I look back at this scenario and I scan through to about the third sentence, at the end of the third sentence, it tells me that the independent testing firm found a mean GPA of 45.5 with a population standard deviation of 1.1. So I am given and I know the population standard deviation. So again, we're going to do a 1 mean Z-test because I know the population standard deviation. Okay, that's what tells me to do the 1 mean Z. So then I begin my process. Step 1 is to state the hypotheses. And again, what I would tell you to do when you're working through the homework problems for this is to actually go through these steps on your paper like I'm doing, and then go back to the computer and answer the questions. Okay, so again, we usually see the null written on the top and the alternative written on the bottom. They have to be clearly labeled. So if I go back, and again, I'm looking for words like claim, believe, think, and again, I tend to have them towards the end of the problem in the form of a question, perhaps. So this says, is there sufficient evidence to show that the cars have an incorrect manufacturer's miles per gallon rating? Okay, now you have to also go back up here and pick up that the manufacturer is claiming that it is 45.6 miles per gallon. And it explains what it means by that phrase, incorrect. Okay, so your hypothesis basically has said incorrect which means not equal manufacturer mile per gallon rating, which is 45.6. Okay, so again, you have that phrase, not equal. Okay, so not equal is the symbol, the equal line with a slash through it. Again, not equal, that's going to be the alternative. So in my alternative hypothesis, I would write that the mean is not 45.6 miles per gallon. And again, that's the one that's given. I can figure out what the null should be in this case because they are the exact opposites. The opposite of not equal would be equal. So my null hypothesis is that the mean equals 45.6 miles per gallon. Step 2, I need to identify the players. Whoops. Again, I tend to make a table. You'd have to identify the population mean, the population standard deviation, sample mean, sample size, your significance level, and then also think about your confidence level. You need to get familiar with those symbols, okay? So if I go back and I read, I know that my population mean comes from my hypothesis, so it is 45.6. Again, if I begin in about the third sentence, it says, after testing 240 cars. So my sample size, it doesn't literally call it a sample, but it said it tested 240 cars. So my sample size was 240. The independent testing firm found a mean, and again, you have to kind of read between the lines because it's talking about those 240 cars. So this is your sample mean of 45.5. So my sample mean is 45.5 with a population standard deviation of 1.1. So my population standard deviation highlighted in yellow is 1.1. And then it says, is there sufficient evidence at the 0.01 level of significance? So my level of significance is 0.01 or 1%. So my confidence level is 99%. So I've gathered all of the information. Step 3 is to calculate the test statistic and its p-value. each test statistic has its own unique p-value. We do that in Minitab. Walking through again, stat, basic statistics, one sample Z. Again, we have summarized data. We tested 240 cars. The sample mean was 45.5. The known standard deviation was 1.1. That's the population standard deviation. We are performing a hypothesis test. My hypothesized mean was 45.6. All of that information is given in the problem. We go to options. My confidence level this time is 99%. My hypothesized mean, let me go back and double check. The symbol in the alternative was not equal because it said incorrect, not equal manufacturers. Okay, so my alternative hypothesis contains not equal. I'm going to select the one with not equal. I click OK. I click OK again. Again, I have to scroll down just a little bit to find the test. Okay, so we get our information from Minitab. You do have to, you would write it down. Okay, I'm copying and pasting so you can see it here on the screen, but you would actually record it. So my Z test statistic is negative 1.41, and the corresponding p-value is 0.159. Those come directly from Minitab. Step 4 is to make my decision. Again, the decision is either to reject the null if P is less than or equal to alpha, or we fail to reject the null if P is greater than alpha. So I'm going to make that comparison. Again, I like to write it down. So I have my p-value compared to alpha. Okay, so my p-value for Minitab is 0.159. We were asked to use a significance level of 0.01. Again, when you're making this comparison, do it digit for digit. The first digit after the decimal for the p-value is a 1. For the level of significance is a 0. 1 is greater than 0, so the p-value is greater than alpha. If P is greater than alpha, again, we would say fail to reject the null. And again, if we fail to reject the null, okay, that means that the null hypothesis is true or valid based on the sample evidence. So again, if I go back to the beginning where we stated our hypotheses, based on the evidence we have proven that this statement that the manufacturer's miles per gallon rating is 45.6 is true, and the fact that it's not is false. And the last step in the process, step 5, is to write a conclusion. You have to include the level of significance in your conclusion. I always begin with that. I would say at the 0.01 level of significance. The manufacturer's mile per gallon rating is, or you could say equals, correct at 45.6 miles per gallon. Now again, I could have just said is 45.6 miles per gallon. Again, if I am mirroring or using the phrasing from the problem, I changed it from being incorrect to correct, because again, based on the evidence, I proved it was 45.6 miles per gallon. Questions? Okay, let me see if I can do one more example, because that way you have an example where you had a less than, you have an example where you have a not equal, and I believe this third example will give you one of a greater than. That way you have an example of each type. Okay, so we read the problem, and it says, the director of research and development is testing a new medicine. She wants to know if there's enough evidence at the 0.05 significance level that the medicine relieves pain in more than 306 seconds. For a sample of 60 patients, the mean time in which the medicine relieved, I got a word missing, sorry, relieved pain was 312 seconds, with a population standard deviation of 22. Now, this problem is maybe set up a little bit differently in terms of the way it's worded, but again, the first decision you have to make is which test you're going to do. Are you doing a one mean Z or a one mean T? Z is used whenever you know the population standard deviation. Otherwise, you're going to use a T. So if I go back and read really the last sentence, the last phrase says, with a population standard deviation of 22. So again, because it tells me the population standard deviation, I know that I'm going to do a one mean Z-test, because I know the population standard deviation. And then I'm going to begin the process. Step 1 in the hypothesis testing process is to state the hypotheses. Again, normally you'll see them stacked. The null hypothesis is on the top. The alternative hypothesis is on the bottom. Again, when I'm looking for my hypothesis, I look for phrases like believe, think, conclude. And so the second sentence says, she wants to know if there is enough evidence at the 0.05 significance level that the medicine relieves pain in more than 306 seconds. Okay, so her phrase is more than 306 seconds. Again, if I stop and think about what that phrase means, the word more than, I think of the math symbol for greater than. So greater than 306 seconds. Since it is greater than and does not include an equal sign, this statement is the alternative. So my alternative hypothesis here is that my mean is more than 306 seconds. Again, that's the one that's given. I can then figure out my alternative, the null, because I know that the null is the exact opposite. The exact opposite of more than is less than or equal. So my null is that the mean is less than or equal to 306 seconds. Remember, the null must always and forever contain equal. Then step 2, we identify the players. I have to identify the 5 pieces of information that I need to work the problem. We need the population mean, the population standard deviation, sample mean, sample size, significance level, and the corresponding confidence level. The population mean is the value that is in the hypothesis, which in this case was 306. So again, if I go back and read through the problem, at the 0.05 significance level, if I start in the second sentence, so my significance level is 0.05 or 5%, which means my confidence level is 95. Let's keep going. The medicine relieves pain in 306 seconds for a sample of 60 patients. Okay, so my sample size was 60. The mean time in which the medicine relieves pain was 312 seconds with a population standard deviation of 22. So my sample mean was 312 and the population standard deviation was 22. So I have all of my information that I need to work the problem. Everything's given to me in the scenario. So step 3 is to calculate the test statistic and its p-value. So we're going to do that in Minitab. Walk through again. Stat, basic statistics, one sample Z, my summarized data. My sample size was 60 patients. The sample mean was 312. The known population standard deviation was 22. We are doing a hypothesis test. We hypothesized it was more than 306. My confidence level is 95. And we were saying, I'll double check it, but I believe we said was more than. Okay, so the alternative is greater than. So I choose the greater than symbol. I click OK. Click OK. Again, I scroll down to test. And we have my Z test statistic is 2.11. My p-value is 0.017. So I've got those recorded. So now I am down to step 4, where we're going to make a decision. Again, the decision options are you reject the null if p is less than or equal to alpha, or you fail to reject the null if the p-value is greater than alpha. Okay, so I'm going to write it out. I have my p-value, which comes from Minitab. It's 0.017. My level of significance in the problem was 0.05. Again, when you make this comparison, we do it digit for digit. So the first number after each decimal is a 0. Second number is 1 compared to 5. 1 is less than or equal to 5. So P is less than or equal to alpha. Since P is less than or equal to alpha, we reject the null. Now, if we reject the null, that means the null hypothesis is false, wrong, or invalid. And the alternative hypothesis is true or valid. Okay, so this one we came to a different conclusion than we did on the other two. What we proved in this particular scenario is that the null is false or wrong, and the null is true. So when I write my conclusion, we write it in terms of the statement that is true. So the last step, step 5, is to write that conclusion. Again, beginning with the significance level. At the 0.05 level of significance, the medicine relieves pain in more than 306 seconds. So I basically took the statement that was the original hypothesis and put it into my conclusion, because that's what we proved based on the evidence to be true, that it did take more than 306 seconds. Okay, so that is the one mean Z. We don't have time to get into the T, although it's not much different. The primary difference is you do not know the population standard deviation. But I want to leave that for another day. But what that also means is that you now can do hypothesis testing and one mean Z test homework. So you actually have several assignments that are due by Sunday. Okay, you have the Module 2 exam, which is open and has to be taken in one sitting by Sunday, which is February the 12th. You can do class participation 8. You have the Z interval homework to do, T interval homework, and hypothesis testing and one mean Z test homework. On Monday, we will talk about the T-test, which will finish up Module 3. And if I'm not mistaken, if you look at the course schedule, the test for Module 3 will open on February the 15th, which is next week, next Wednesday. Okay. We don't have many days left because this class ends March the 1st. Okay. Do you have questions before we go? All right. If not, then I will hopefully see you on Monday. But if you have questions, you're welcome to email me, or I have office hours this afternoon between 1:30 and 3.